Hello, seventh graders. Welcome to 1.4, where today we'll be discussing how to rewrite equations and formulas. For your learning target, it is I can rewrite equations to solve for one variable in terms of other variables. And while that might sound confusing and like a whole bunch of mumble jumble, I'll give you a kind of simple way to think about that. With our vocab, it relates right to that. So it says an equation that has two or more variables is called a literal equation. So let me give you an example of a literal equation. If I'm talking about the area of a rectangle, its area is equal to its length times width, right? Here you can see we have two or more variables. This is in fact an example of a literal equation. And it says to rewrite a literal equation, solve for one variable in terms of other variables. So say, for example, this problem tells us the area is 12 and its length is 3. How could we find its width? Well, a bunch of you are like, well, yeah, Mr. Yeltsin, I know 3 times 4 would give me 12. But you could rewrite that in this equation. So we know the area, we know the length. How could we rewrite this equation to make it in terms of W? Well, if I wanted to solve this equation for W, I'd ask myself, what is being done to W and how can I undo that? Well, W is being multiplied by L, so to undo that, I would divide by L on both sides. So L divided by L is 1. I'd be left with 1W equals my area divided by my length. If I were to apply that in this problem, area is 12 divided by my length is 3. 12 divided by 3 would give me 4, which would be my width, which you kind of already knew because that was a pretty simple example. But you'll see more complex examples where it's not just that quite simple. So hopefully that gives you a little bit of background information. Let's see another type of example where we have to rewrite another equation. It says solve the equation 2y plus 5x equals 6 for y. So essentially what this means is in the end, they want our equation to say y equals whatever. That's how I would know. That's how I would know it would be solved for y. If it just says y equals whatever that might be, whatever I find. Okay. So if I look at my equation here, 2y plus 5x equals 6, I want my y to be isolated or all alone in the end, right? So the first thing I would do is I would subtract 5x from both sides. This 5x is on the same side as my y. I want to move that to the other side of my equation. 5x minus 5x is 0. I'm left with 2y equals. Now, a common mistake I see is I see students try to take 6 and subtract 5, and then they'll say, okay, 6 minus 5 is 1x. Well, remember, 6 and 5x are not like terms. This 6 does not have an x with it, so you can't subtract. You just have to rewrite this as 6 minus 5x. That's all we can do. And then you'll see that I'm not quite solved for y yet because I'm still multiplying by 2. So to undo that, I would divide by 2 on both sides of my equation. And notice that I'm dividing both of these terms by 2. I have to divide everything by 2. This will cancel. 2 divided by 2 is 1y, which is perfect. That's what I wanted. And now divide both of these terms by 2. 6 divided by 2 would give me 3. And then I've got negative 5x divided by 2. You can just rewrite this as a fraction because After all, they are essentially the same thing. So I'm going to write this as minus 5 halves x. And this is my answer. Y equals 3 minus 5 halves x. Right? I just solved it for y. That's all I did. Kind of restructuring the equation. It's the same thing. It's just, it looks a little bit different. Right? Why don't you go ahead and try that on your own to see how you're doing. And it's the same directions. Sorry, I didn't write that in, but solve for y in each one of these. Go ahead, pause now, and try it out. All right. I'll do a couple here to make sure you're understanding the steps. So first I would move my x to the other side of my equation. Negative x plus x is nothing, and I'm left with 5y equals 10 plus x. And lastly, I need to divide by 5 to get y all alone. And remember, you're dividing everything, both of these terms, by 5. So y equals 10 divided by 5 is 2. And remember, this is x is the same as 1x. So I'll just rewrite this as a fraction like I did this problem. So I'm adding, I covered it up a little bit, but 1 divided by 5, you can just rewrite as 1/5 x. Okay, so y equals 2 plus 1/5 x. The next one, I've got 4x minus 4y equals 1. I want it to be y equals in the end, so I'll first move my x to the other side. I need to subtract 4x from both sides. That can be a common mistake because this is a positive 4x. And to undo that, I need to subtract 4x on both sides. I'm left with negative 4y equals 1 minus 4x. And then I'll divide by negative 4 on both sides. Y equals 1 divided by negative 4 would be negative 1/4. Again, I'm just rewriting it as a fraction. And negative 4x divided by negative 4, well, a negative divided by a negative is a positive. And 4 divided by 4 is 1. And I have 1x, or I could just write that as x. So y equals negative 1/4 plus x. Realize I could switch the order of these around if I want to. So this is the same thing as y equals, remember to keep your signs straight. This is positive x, and this is negative 1/4. So x minus 1/4. These two are the same. Negative 1/4 plus x, or x minus 1/4. My 1/4 is still negative, and my x is still positive. Likewise, you could do the same here. You could say this is the same as y equals, maybe I want to write my x first, 1/5 x plus 2. All I did was I switched the order of those, and that's okay as long as you keep your signs the same. All right? It just takes a little bit of practice. All right, let's try number 3. Again, I'm solving for y, so I need to move my x to the other side. To undo that, I would subtract 6x from both sides. Okay, those would cancel. I'd be left with 3y on the right-hand side equals 12 minus 6x. Again, you can't subtract them. This does not have an x. Last step, divide by 3, and we're dividing everything by 3. So 12 divided by 3 would be 4, and negative 6 divided by 3 would be negative 2x. Don't forget about your x. Equals y. That looks a little bit confusing, so I'm going to write my y first. So I'm going going to say, or y equals, and then I got 4 minus 2x. Or remember, you could change the order of these two if you wanted to. You could say that's the same as y equals and keep the signs in front of the terms. Negative 2x, this is positive 4, so plus 4. This is my final. Okay, so again, lots of different kind of ways to write them in the end. Make sure you're dividing both sides by that same term, I think, is a key that I see quite a bit in these examples. All right. Now, for example 2, we get a little bit more into formulas. So it says the formula for the surface area S of a cone is S equals pi r squared. Oops, sorry, I don't have that pi symbol must have not carried over. Pi r squared, you might have to write that in your notes as well, plus pi times radius times length. Solve the formula for the slant height L, which is right here. Right now, our formula is solved for surface area. So it's S equals pi r squared plus pi radius times length. That's just this right here. I'm just rewriting it. And it wants me to rearrange this formula so that I'm solving for the slant height, or L, which is right here at the end of my equation. Okay. Whew. Going to be a little work here. Let's try to keep everything straight. So, split it at the equal sign. Here's my L. I see that's being multiplied by radius and being multiplied by pi. And it's also being added by pi r squared. So I'm going to move this piece of information first to the other side to kind of get my pi rl alone, just like I did in the previous examples where I would subtract like an x first. I'm going to subtract this pi r squared. Pi r squared minus pi r squared cancels out. I'm left with 0. And what I do to the right, I need to do to the left. So I need to subtract pi r squared. Notice I don't have any like terms here. So I'll just rewrite this as s minus pi r squared equals pi times radius times length. All right. And now, how would I get L all alone is what I should be thinking. Well, my slant height L is being multiplied by r and by pi. So how can you undo multiplication? Well, you could just divide it. And you can divide pi r in the same step at the same time. So I could divide by pi r at the same time on both sides. Pi divided by pi is 1. R divided by r is 1. And now I've isolated my slant height, L, equals my surface area minus pi times radius squared divided by pi times radius. And there is my confusing formula rewritten for my slant height. All right. If you were to Google that, the slant height of a cone, you would find a formula that's similar to this. We just rewrote the formula. It was solved for surface area, and we just rewrote it for slant height. Okay. So try the 4, 5, and 6 on your own problems that are similar. Excuse me. And we just need to rewrite them in terms of the red variable. Okay. So I've got, for number 4, A equals B H. So I'm going to, I want to solve it for the red. So in the end, I want it to say B equals. So how do I get B all alone here? Well, I just divide by H on both sides. H divided by H cancels. And I'm left with B equals A over H. This one is kind of similar to that rectangle area problem. Number 5, simple interest. Oh, actually, it is the area of a rectangle. I didn't even look at that. They just used base and height instead of length and width. For number 5, we're solving for P. We start off with interest equals principal times rate times time is what those stand for. And I want to solve for P. In the end, I want it to say P equals something. Right now, P is being multiplied by R and T. So to undo that, I would divide by R and T on both sides, which cancels. And then I'm finished. P equals interest divided by rate times time. Right? And lastly, we go back to something similar to the last example, but now we're talking about the surface area of a cylinder. Change colors here, and I want to solve for H. So first I'll subtract 2 pi r squared on both sides of my equation. So I have S minus 2 pi r squared equals, these canceled, 2 pi r h. Trying to solve for h here. So I see that's being multiplied by r and by 2 pi. So I'll just divide by 2 pi r. And I'll do that on both sides. Divide by 2 pi r. That cancels. Anything divided by itself is 1. And I'm left with h equals s minus 2 pi r squared divided by 2 pi r. The more you do these types of problems, the better you get it. Okay. Moving on to the key idea here. It says a formula for converting from degrees Fahrenheit F to degrees Celsius is C equals 5/9 times F minus 32. All right. So this is a quick conversion to go from Celsius to Fahrenheit or vice versa. And what we want to do in example 3 is solve the formula for Fahrenheit. Okay. So here's what we start with. C equals 5/9 times F minus 32. But we want to solve this, so in the end it says F equals. All right, so I'll rewrite my formula. C equals 5/9 times F minus 32. And what I am going to do first is I want to move this fraction here. This is like saying I'm taking 5/9 and I'm multiplying it by all of this. So to undo multiplying by 5/9, we would divide by 5/9 on both sides. Okay, 5/9 divided by 5/9 cancels out. It's 1, right? And then remember, dividing a fraction is like the same as multiplying by its reciprocal. Okay, so instead of writing it as dividing by a fraction, I'm going to rewrite it as multiplying by its reciprocal. So I'm going to say that dividing by 5/9 is the same as multiplying by 9/5. So 9/5 times C is equal to F minus 32 because these cancel out. And then in my last step to solve for F, I just need to add 32 to both sides. This would cancel, and I'd be left with F is equal to 9/5 times Celsius plus 32 degrees. Okay. And you could go Google it and you would find that this is the conversion rate between Fahrenheit and Celsius. Okay, right here, these two. And we just showed how we do that by a little bit of algebra. Okay. There is no on your own for this last example, so I'd like for you to actually pause and try this example 4 on your own and see how you do. All right, it says which one is greater, the sun with 11,000 degrees Fahrenheit or lightning at 30,000 degrees Celsius? What I'm going to do is I'm going to change this Celsius into Fahrenheit because I am familiar with Fahrenheit and how that feels. So I'm going to use my Fahrenheit formula that I just figured out of Fahrenheit is equal to 9/5 times Celsius plus 32. Okay, I'll plug in my Celsius. So Fahrenheit equals 9/5 times, well, the Celsius of lightning is 30,000 plus 32. A little bit of calculator work here. 9/5 times 30,000 would give you 54,000 plus 32 would give you 54,032 degrees Fahrenheit. Wow, that is impressive. So lightning is the same as 54,032 degrees Fahrenheit, which has a greater temperature. Lightning does by almost 5 times. That is impressive. You hear people getting struck by lightning and surviving it, so that's pretty crazy. All right, that does it for 1.4. Let me know if you have more questions. As always, the best way to get better is more practice. I'll see you next time.